Alright, in this video we're going to talk about scientific notation. Scientific notation is used a lot in our calculations this semester. It is a way to express very large or very small numbers without having to write all the zeros. In order to explain how to use scientific notation and what it is, I'm going to write a couple of numbers in scientific notation and then we'll talk about the patterns. For example, 123 expressed in scientific notation is 1.23 times 10 to the second power. The number, I'm not even going to call it out, I'm just going to draw it, is 4.52 times 10 to the 8th. The number is 3.6 times 10 to the 11th. Alright, what these numbers have in common, expressing it over here on the right in scientific notation, is a way to express, especially these last two, the large numbers without all the zeros. And how it works is I have written a digit, a decimal, any other digits, times 10 raised to a power. A digit, the decimal, any other digits, times 10 raised to the power. This last one I have written a digit, a decimal, a second digit, times 10 raised to the power. That's the notation. Always one digit, then the decimal, then any other digits, times 10 raised to a power. This power, the power of 2 in this case, indicates how many places the decimal place has moved from my original number. These two are equivalent. 123 is indeed 1.23 times 10 squared. If you punch that in your calculator, you would see that that was the same. But the 2 tells me that this decimal place has moved 2 places between this number and that number. There's a 2 decimal place shift. In this case, here's my decimal place. It's moved 8 places in this number, if I counted right. In this number, the decimal's over here. It's not written explicitly because I don't want all those zeros to be counted as significant, but it is here, and there's a 1, 2, 3, 4, 5, 6, 7, 8 place shift, I counted right, to get it to right after the 4. In this number, there's a movement of 11 places to get it here right after the 3. So from here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I counted that one right too. So we have that number in scientific notation. Alright, let's look at a couple of more numbers in scientific notation and see some patterns here. If I have the number 0.0025 in scientific notation, that is 2.5 times 10 to the minus 3. If I have 0.0000, let me just draw it. Alright, that is 3.89 times 10 to the minus 9th, if I counted right. We'll check it in a minute. If I have 0.0000, 6580, that is 6.580 times 10 to the minus 7th. Alright, let's take a look at these and look at their exponents. Again, the notation is exactly the same. I have a digit and a decimal, any other digits, times 10 raised to a power. In this case, the exponent is negative 3. The 3 again stands for the number of places the decimal place moves, 1, 2, 3, to get it right there after the 2. But it's negative because now I'm represented a small number. When you have small numbers, you have negative exponents. Up here, I had large numbers, and I have positive exponents. Down here I have small numbers and I have negative exponents. Small numbers being numbers that begin with decimal places. In the second example, my decimal is here in scientific notation right after the 3. My exponent is a -9. That means, whoops, not from there, but from here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, if I counted right, 9 places that decimal place was moved to here, not to the end, but to right after the 3 like it is in my scientific notation. So this is 3.89 times 10 to the -9th. Here the decimal is moved 7 places, again from here either direction. 1, 2, 3, 4, 5, 6, 7. My decimal is right after the 6. The proper notation, recall, is a digit, then the decimal, then the rest of your digits. Just to point out in this last one, just to show something from our last video, this 0 at the end is counted as significant, or else it wouldn't have been written. It is significant at the end of a number if there's a decimal place written. And so when I write this in scientific notation, I still write that last 0 to indicate that it is significant.